Hello everyone, my name is Aditya Santosh Rote. I am a first year engineering student pursuing B.Tech in Information Technology from KBD College of Engineering, Nashik. Today, for my basic electrical engineering project, I will be presenting on the topic DC motor application in electric vehicles. We often see EVs on the road, but today I want to explain the engineering behind them, especially how we apply the DC motor concept we learned in class to modern transportations. Now we will go to the second slide, Introduction to EVs Propulsion System. Let's start by understanding the system. As you can see here, the propulsion system consists of a battery containing a controller or a inverter, which then drives the electric motor to turn the wheels. The main function of this motor is to convert electric energy into mechanical energy. For the electrical vehicles, we have three key requirements for the motor. First one is high starting torque. We need massive power to accelerate a heavy vehicle from a standstill. The second one is high efficiency. This is crucial for maximize the driving range and battery life. Third one is regenerative braking. The ability to act as a generator and recharge the battery when slowing down. Now we go to the third slide, working principle of a DC motor. Now let's look at the physics, which comes directly from a BEE syllabus, the fundamental principle in the Lorentz force law. When a current carrying conductor is placed in the magnetic field, it experiences a mechanical force which will be calculated by the formula F is equals to BIL sin theta, where B is magnetic field, I is current, and L is the length. The direction of this force is determined by the Fleming's left hand rule. A crucial component shown here is the commutator. It acts as a mechanical switch that reverses the current direction every half turn to ensure the motor keeps spinning in one direction. Now we will go to the fourth slide, the DC series motor. Moving to the specific type of motor historically used for traction that are the DC series motors. As you can see in the circuit diagram, the field winding RSE is connected in series with the armature RA. Is connected in series with the armature RA. This means the same current flows through the entire motor, which means I load is equals to I field is equals to I armature. But why this is important? In a series motor, the magnetic flux phi becomes proportional to the current. Since torque T is proportional to the flux times current, which means T is directly proportional to phi and I, and flux is proportional to current, the final torque becomes proportional to the square of the current, which means T is directly proportional to square of the I. Now we will go to the fifth slide, torque speed characteristic of DC motors. This unique relation T is directly proportional to I square leads to the characteristics shown in the graph. First, we get high starting torque. Because torque is proportional to the square of the current, even a small increase in the current gives a huge boost in torque. This makes it perfect for starting a heavy EV from a standstill. Second, it offers self-regulating speed. When going up hills, the speed naturally drops and torque increases. But on a flat road, the speed increases. This automatically adjustment acts almost like a virtual gearbox. Now we'll go see the slide number 6, the limitation of brushes of a DC motor. However, this traditional brushless motor have challenges. There are main challenges for a brush DC motors. The first one is maintenance. The carbon brushes physically rub against the commutator and wear out over time, requiring replacement. Second one is sparking. Friction at high speeds causes sparking, which is a fire hazard and causes electromagnetic interference. The third one is heat dissipation. Heat is generated inside the rotor, which is very difficult to cool down compared to the outer setup. The fourth one is speed. The physical content limit the maximum RPM, which is speed limit. Now we will see the slide number 7, the modern solution brushless DC BLDC motors. To solve these problems, we use the brushless DC motors. Think of this as an inside-out DC motors. The rotor moving part carrying permanent magnet of there are no coils or current on the inside. The stator, a fixed part, carries the copper winding which makes them very easy to pull. Here we can see, here is the stator and here is the rotor. Instead of mechanical brushes, we use an electronic controller to switch the current. This results in zero sparking and low maintenance and much higher efficiency. Now we will see the slide number 7, the difference between the brushed and the brushless DC motors. Like here is a quick comparison. The first one by the commutation. Brushed DC use mechanical brushes while BLDC use electronic controllers. The second one is maintenance. Brushes motors have high maintenance due to wear, whereas BLDC have very low maintenance. The third one is efficiency. BLDC motors have significantly more than 85 to 95 compared to the brush motors have 75 to 80%. The fourth one is safety. BLDC motors eliminate the spiking hazards found in brush motors. Also, the cost. The cost of the brush DC motors is low, but when you compare them by the BLDC motors, the BLDC motors have the higher cost. Now we will see this slide number 9. Looking ahead, the technology is still evolving. PMSM, which means Permanent Magnet Synchronous Motor. These are used in high performance EVs like Tesla and the Tata Nexon EV for even higher power densities. Switch reluctance motors means SRM. This doesn't use permanent magnet, it uses rare earth metals, making them cheaper and more result. The third one is axial flux motors. These are the new pancake shaped motors that are thinner and lighter used in high-end sport cars. Now we at the end of the PPT. Here is the conclusion. In conclusion, electric vehicles rely on the efficient conversion of electrical to mechanical energy. The DC series motor helps us to understand the fundamental needs of high starting torque, which is T is directly proportional to I square. However, BLDC motors have become the modern industry standard due to their high efficiency and low maintenance. The future is moving towards the lighter and the smarter motors like PMSM and many more. Thank you.